Hi, in this video, we will discuss the plane configuration of a complete endpoint and a complete endline. First, let's define what a plane configuration is. It is any figure in the projective plane that consists of a sub 1 number of points, a sub 2 number of lines, a sub 1 number of lines on each point, and a sub 2 number of points on each line. Now, the subscripts 1, 2, and so on represent the row or column in an array. Hence, a plane configuration is written as an array of this format. So, in the first row and first column of the array, we have the number of points. In the second row and second column, we have the number of lines. In the first row and second column, we have the number of lines on each point. And in the second row and first column, we have the number of points on each line. Therefore, the first column pertains to the points, while the second column pertains to the lines. On the other hand, the first row pertains to each point, and the second row pertains to each line. Now let's introduce the complete endpoint. It is a type of plane configuration that consists of endpoints, no three of which are collinear or on the same line, and the 1/2 times n minus 1 number of lines determined by the set points. A complete endpoint is also known as the complete quadrangle. So let's consider the complete 4 points. So we have here 4 points, 1, 2, 3, and 4. So we have 4 points. If we connect each pair of 2 points using a line, we will have 1, 2, 3, 4, 5, and 6 lines. So we have 6 lines. Now let's consider a point. So for example, this point. And count the number of lines going through that point. So note that we have 3. Therefore, we have 3. Hold on. Let's consider another point. Let's say this one. So again, we have 1, 2, and 3 lines going through that point or on that point. Therefore, we have 3 lines on each point. Now, let's consider a line. For example, this line. How many points do we have in this line? We have 1 and 2. How about another line? Let's say this other diagonal. Okay. Yes, we can see that there are also 2 points on that line. Okay, so therefore we have 2 points on each line. So the plane configuration of a complete 4-point is, so we have 4 points. We have 4 points. 6 lines, 3 lines on each point, and 2 points on each line. This time we have the complete endline. It is also a type of plane configuration, but this time it consists of endlines, no three of which are concurrent, and the 1/2 times n minus 1 number of points determined by the set lines. The complete endline is also known as the complete quadrilateral. For the plane configuration of a complete endline, we have a shortcut. So we start with a plane configuration for the corresponding complete endpoint, and we simply interchange the numbers in each diagonal of the said plane configuration. For example, we have this plane configuration for for a complete endpoint. So let's say we have here 7, 6, 2, and let's just say that this is 17. Okay, now, so based on this, we should be able to get the plane configuration for the corresponding complete endline. So for that, we simply interchange the numbers in each diagonal. So we have here 7 and 17. If we interchange the two numbers, we get 17 and 7. We also have here 6 and 2. Interchanging them, we get 2 and 6. Okay, so that is a shortcut for the plane configuration of a complete n line. Now let's consider a complete 4-line. So we need 4 lines. Okay, so we have this first line, and then this second line that should intersect the first one at one point. Then we have a third line that should intersect with the first two lines. So we have these points of intersection, and finally we have this fourth line that should intersect the first three lines. So we have this 3 point of intersections. So that gives us 4 lines. Now, how many points do we have here? So we have 1, 2, 3, 4, 5, 6. So we have 6 points. Okay, now let's consider a point. So let's say this one. How many lines, okay, are on this point? We only have 2. How about another point? So let's say this point. Okay, again, we have 2 lines on that point, so therefore we have 2 lines on each point. Okay, now let's consider a line. So let's say this line. How many points are on this line? We have 3. How about another line? Let's say this one. Again, in this line we have 3 points, therefore we have 3 points on each line. So the plane configuration of a complete 4-line is we have 4 lines, 6 points, 2 lines on each point, and 3 points on each line. As we've seen in the previous examples, it is relatively easy to write the plane configuration when we have only a few points or a few lines. But that is not the case when we have, say, 50 points or 70 lines. That is why we have this general approach for the plane configuration of a complete endpoint. So given a complete endpoint, we have endpoints. And we also have the requirement that no 3 points are collinear. So so that means that only 2 points can form a line. Okay, therefore for the number of lines, we have to get the combination of endpoints taken 2 at a time. So we can use this formula, which is also equal to 1/2 times n minus 1. Next, for the number of lines on each point, we have n minus 1. Because every point, okay, can form a line with every other point, right? So for example, you have 4 points. So 1, 2, and 3, and 4. So if we are considering this point, that can form a line uh, with each of the other points. In this case, 3. So you see, you have 4 points, okay, and on each point, for example, at this point, we have 3 lines, or that is 4 minus 1. Okay, next for the number of points on each line, remember, since a complete endpoint requires that no 3 points are collinear, for any plane configuration, for the plane configuration of any complete n line, we only have 2 points on each line. Let's consider 3 examples. First, we have the plane configurations of a complete 6-point and a complete 6-line. For a complete 6-point, we have 6 points. For the number of lines, we have the combination of 6 points taken 2 at a time. So that's 1/2 times 6 times 6 minus 1, and that is equal to 15. For the number of lines on each point, we have n minus 1, so that is 6 minus 1. that is equal to 5. And remember, for any complete endpoint, we only have 2 points on every line. Therefore, the plane configuration, for the plane configuration, we have 6 points, 15 lines, 5 lines on each point, and 2 lines on each, rather 2 points on each line. For the plane configuration of a complete 6 line, okay, we can simply interchange the numbers in each diagonal. So first we have 6 and 15. Therefore, we have 15 and 6 for the complete end line. Given to with this 2 and 5, so we have here 5 and 2. Next example, we have the plane configurations of a complete 15 point and a complete 15 line. So for a complete 15 point, obviously we have 15 points. For the number of lines, we have the combination of 15 taken 2 at a time. So that's 1/2 times 15 times 15 minus 1. That is equal to 105. For the number of lines on each point, so we have n minus 1. So that is 15 minus 1, which is equal to 14. And again, for any complete endpoint, we only have 2 points on every line. So for the plane configuration, we have 15 points, 105 lines, 14 lines on each point, and 2 points on each line. And again, for the plane configuration of 15 line, hold on. For the plane configuration of a complete 15 line, let's interchange the numbers in each diagonal. So we have 15 and 105. Therefore, we have 105 points and 15 lines. And then we have it 14 and 2. So therefore, for the complete 15 line, we have 2 lines on each point and 14 points on each line. Finally, we have the plane configurations of a complete 35 point and a complete 35 line. So for a complete 35 point, obviously we have 35 points. For the number of lines, we have, okay, the combination of 35 taken 2 at a time. That is equal to 1/2 times 35 times 35 minus 1, which is equal to 595 lines. For the number of lines on each point, we have n minus 1. So we have 35 minus 1, which is equal to 34. And again, remember that for any complete endpoint, we only have 2 points on every line. So for the plane configuration of a complete 35 points, we have 35 points, 595 lines, 34 lines on each point, and 2 points on each line. Now for the plane configuration of a complete 35 line, we simply have to interchange the numbers in each diagonal of the uh, first plane configuration. So we have 35 and 595. So for the complete 35 line, we have 595 points, 35 lines. Now let's also interchange, okay, 34 and 2. So we have 2 lines on each point and 34 points on each line. And that's it for this session. Thank you for watching.